Okay, this is on trigonometric functions of special angles. We're going to look at quadrantals, 30, 60, 90, and 45, 45, 90. So it's trigonometric functions, and we'll look at all 6 trig functions: sine, cosine, tangent, cosecant, secant, cotangent. Trigonometric functions of special angles. Okay, first we're going to look at the special cases for quadrantal angles. Remember, on quadrantal angles, the initial side starts on the positive side of the x-axis in standard position, and then the terminal side has to lie on either the x or y axis. Okay? In all of this, for the quadrantals, we're going to use what they call a unit circle. And a unit circle has a radius equal to 1. Okay? So when you look at a unit circle, the radius of your circle is equal to 1. Okay? First one we're going to look at for the quadrantal, and we're going to look at several pictures. And on all these, you do want to draw a sketch. You know, in trig, that's the critical part, is to draw a sketch. So if you're on the positive side of the x-axis, and if the unit circle was a radius of 1, and let's look at 0 degrees. If we're at 0 degrees, we're in quadrant 1, and it won't form a triangle. So what you do is you pull that out away from the axis. Okay? So, and we've already done that in the other section. You take that terminal side, you pull it out away from the axis, and the perpendicular will always go back to the x-axis. Okay? And now this represents your 0 degrees inside the triangle at the origin, and this represents, because if you squish this side back together, it actually represents 0. And we're in a unit circle radius of 1, so this is 1. We went positive 1 to the right, and the hypotenuse is 1. So when you look at all 6 trig functions, like if we were doing sine of 0 degrees, now instead of putting in theta, we can actually put in 0 because we know what the angle is. Sine of theta, and for a while I asked that you write down the definition. Okay, don't skip that step. Don't just give me a number. I want the sine of theta equals opposite over hypotenuse equals. Okay, and then if you're looking at this angle inside the triangle, so the opposite side would be 0, and the hypotenuse would be 1. 0 divided by anything is 0. Okay. The next one would be cosine. It's sine, cosine, and then tangent. So cosine is 0. Definition: cosine is adjacent over the hypotenuse. So in our picture, touching this 0 degrees adjacent to that is this side, 1. So 1 over the hypotenuse. Remember, the hypotenuse is always the one opposite the right angle. So the cosine is 1. And then tangent. Tangent is opposite over adjacent. So in our case, the opposite side would be 0. Adjacent side would be 1. Okay, and that's 0. Okay, now you do the other 3, and it's customary in trig to do the first 3, the reciprocal's right beside it. Okay, so reciprocal of sine is cosecant. So cosecant of 0 degrees is the hypotenuse over the opposite. Okay, so the hypotenuse is 1, the opposite is 0. Now, some books will say undefined, but in this case, we're going to go ahead and say that that is infinity. And on the graphs, you will actually see the graph, the y value go to infinity, okay, when we get to the graphing part. Reciprocal of cosine is secant. So secant of 0 degrees is the hypotenuse over the adjacent. So the hypotenuse is 1, the adjacent's 1, and that's 1. And then cotangent. Cotangent of 0 degrees is adjacent over opposite. So the adjacent is 1, the opposite is 0, and you can't divide by 0, so that's infinity. Okay. Notice on this, last week I said that the reciprocals multiply together to give you 1. Well, this is going to be the exception, because when you get like sine is 0 and cosecant is infinity, when you multiply those together, you're not going to get 1. The quadrantals, you're going to get some special cases there. Okay, but this one, 1 times 1 would give you 1. Okay. So when they ask you on the table, you're going to fill out the table, and I'll give you a sheet for that. I want you to go through all 6 trig functions, okay? And don't skip that step of writing out. Don't skip this step, okay? Write that out for a while, okay? Okay, that's 0 degrees. Now, what we're going to do is we're going to go through the quadrantal angles for all the way around in all the quadrants. So the next one, I just want to go through the pictures, and then you will fill out all 6 on your table. Okay, so the next one I want you to look at is 90 degrees. Okay. Okay, if I do 90 degrees, I would start here on the positive side of the x-axis. Okay, and then I would go to here. Okay, we're still in a unit circle with a radius of 1. There is no triangle. So you pull that terminal side out away, and I don't care if you go left or right. I usually bring it back here, but the perpendicular goes back to the x-axis. It won't ever look like this. It won't go back to here and back to there. That won't ever happen. It won't ever go back to the y-axis. It always, perpendicular always goes back to the x-axis. Okay, so if we squish this back together, right here, this is the 0. Okay, if you put it back on that axis, this is the 0. It first started out like that. Okay, so if we take this out away and put that back, now squeeze this back together, so this terminal side right here goes back to that axis. Okay, so this actually represents the 0. Okay, and this, it doesn't look like it, but this angle inside the triangle at the origin represents our 90 degree. Okay, now this is 1, and the hypotenuse is always positive, it's 1. So when you do your sine, cosine, and tangent, okay, you're going to look at the angles inside the triangle at the origin. This one would be our opposite, 0 would be our adjacent, and this one would be our hypotenuse. Okay, so this is the picture for 90 degrees. Okay. Okay. The next one would be 180. Okay. So for 180, for 180 degrees, you would actually start here on the positive side of the x-axis. You would rotate over here 180 degrees. Okay. Now you can't see a triangle there. Okay, so you take that and you pull that out away from the axis. I don't care if you go up or down, as long as you go the perpendicular. I usually take it up, okay, and the perpendicular goes back to the x-axis. Okay. Now this represents our 0. If we squish this back together, okay, it comes back to that where we started. So this represents the 0. Now this is -1 because we're going to the left. It's critical in trig that you remember left is negative, down is negative. The hypotenuse is always positive. And when you're looking at, this is actually the angle you're looking at for your theta, the angle inside the triangle at the origin. So 0 would be, from this angle, 0 would be the opposite, -1 would be the adjacent, and 1 would be the hypotenuse. Okay, okay, the next one is 270, for a sketch for 270. So 270, we would start on the positive side of the x-axis in standard position, go around, okay, drop the, and there's our terminal side. Again, you don't have a triangle, so you've got to pull that terminal side out away from the x-axis. Pull that out away from the x-axis, and the perpendicular goes back to the x-axis. Okay, so now this represents our 0. Okay, this would be -1 because we're going down, and this would be +1. And this actually represents our angle in here. That's our 270 degree. Okay. Okay, and the last quadrantal is 360. So for 360, we would start here. We would go all the way around, and our terminal side would also be there. So for 360 degrees, okay, and we don't have a triangle. So to be able to visualize it, the whole idea is to visualize it so you can figure out what's the opposite, the adjacent, the hypotenuse. Pull that out away from the axis. The perpendicular always goes back to the x-axis. So this represents the 0. If you squish those back onto that x-axis, this would represent 1, and this is 1. And now you're looking at this angle inside the triangle. So the 0 would be the opposite, the 1 would be the adjacent, and the 1 would be the hypotenuse. And then you go all through all 6 trig functions. Okay. Okay. Any questions on that? Okay. Those are the quadrantal angles. Those are the special cases. I always people always ask, well, oh, I get confused. Is it when you're doing this part? Is that 0 or is that infinity? If you ever forget that on the test, you go back to one that you know. Go back to like 6 divided by 2 is 3. How do you check division? Multiply. So we would multiply. 3 times 2 is 6. Yeah. So if I said 0 divided by 1, if I said that's 0, then I should be able to check it and say 0 times 1 is 0. Yeah, that checks. If I said 1 times 0 equals 0, then you're saying 0 times 0 equals 1? No. That's the infinity. Okay? So if you forget, go back to one that you know and say, okay, how do you check that? Okay? Okay. Put a little divisor there, separator. Now we're going to look at the special cases for 30, 60, 90. You actually did these and spent quite a bit of time on them in geometry. The 30, 60, 90 right triangles. We're going to spend time on 30, 60, 90, 45, 45, 90, and then we're going to go the next time we'll go to any angle. So these are the special case, and these are, because they're 30, 60, 90, they are right triangles. Okay. And on these, you do want to draw the pictures. Okay. On a 30, 60, 90, okay, just estimate, say we're starting on the positive side of the x-axis. Okay, estimate about a 30 degree angle. The perpendicular always goes back to the x-axis. Okay, so this is our 30 inside the triangle at the origin. This is our 60. Remember, there's 180 degrees in every triangle. If it's a right triangle, the other two are complementary. They have to add up to 90. Okay, standard labels in trig. Okay, and they will always 30, 60, 90s will always be in this ratio. Okay. But our standard labels in trig for what we're doing right now, standard labels, the side opposite to 30 is 1. The side opposite to 30 is 1. The hypotenuse is twice that shorter leg. How do you know which one's the shorter leg? It's opposite the smaller angle. So it 30. The side opposite the 30 has to be the shorter leg. The hypotenuse is twice that shorter leg. So the hypotenuse is 2. And the longer leg is radical 3 times the shorter leg. So radical 3 times 1 is just radical 3. Okay? So this is the picture, if you want to label it, this is the picture for the 30 degree angle. And the opposite side would be 1. The adjacent side would be radical 3. And the hypotenuse would be 2. And then you write down all 6 trig functions and fill in. Okay? And we're going to go all through all 4 quadrants. Okay, now draw a picture for 60 degrees. Okay? So you start on the positive side of the x-axis, rotate up about 60 degrees. Okay, notice I don't care to the length, I'm just drawing the sketch. These are just sketches. The perpendicular always goes back to the x-axis. This angle inside is 60, so that makes this 30. Okay. Standard labels in trig. The side opposite the 30, is 1. The hypotenuse is twice that shorter leg, 2. The longer leg is radical 3 times the shorter leg, so radical 3 times 1 is radical 3. And in quadrant 1, they're all positive because you're going to the right, you're going up, and the hypotenuse is always positive. So this is the picture for a 60-degree angle. Okay. Okay, another picture. Everybody done with that one? Okay. Okay, the next one. We're going to do 120 degrees. 120 degrees, you start on the positive side of the x-axis. This would be 90, and how much more? 90 plus 30. So if that's true, if this is 120, what's this angle in here? 60. So it is a 30, 60, 90 right triangle. So you have to figure out what's the angle inside the triangle at the origin. The side opposite the 30 is 1, but we're going to the left. Okay, that's a critical part. The hypotenuse is twice that shorter leg. The hypotenuse is always positive, and the longer leg is radical 3 times the shorter leg, and it's positive because it's going up. So this is our picture for 120 degrees. When you do your sine, cosine, tangent on that, you still say sine of 120, even though 60 is your reference angle. Okay, if you did all 6 trig functions with 60, they would all be positive. But in this quadrant, what's positive? Sine and cosecant. It's reciprocal. The other 4 better be negative. Okay, okay, and that's kind of your check at the end. Okay, the next one's 150 degrees. I draw a sketch for 150 degrees. So 150, we'd start here on the positive side of the x-axis. We'd go around 150, and how much more? 150, and we go 90, and how much more? 60. Okay, so that makes the reference angle inside the triangle 30. Okay, if this is 150, and you know that's a straight angle, adds up to 180. So the reference angle inside the triangle is 30. Standard labels in trig. The side opposite the 30 would be 1. How many times have I said that? Have you written it down yet? Okay. Just because I don't write it, you got to get used to the verbal clues. The side opposite the 30 is 1. The hypotenuse is twice the shorter leg. Okay, I've said that several times. The hypotenuse is twice the shorter leg. And the longer leg is radical 3 times the shorter leg. But in this case, we're going to the left, so it's negative. Okay, so that's your picture for 150 degrees. Okay, now let's go into quadrant 3. Let's go 210. Okay, Okay, so if I go 210, I start on the positive side of the x-axis. I go 180, and how much more? 30. Okay. Perpendicular goes back to the x-axis. Okay, so this is 30. So this is the picture for 210. So that makes this 60. Side opposite the 30 is 1. But we're going down, so it's negative. Put that 210 in another spot. Okay. The hypotenuse is twice that shorter leg, and it's always positive. The longer leg is radical 3 times the shorter leg, and we're going to the left, so it's negative. In that quadrant, what should be positive? Tangent and cotangent. It's reciprocal. That's in quadrant 3, tangent and its reciprocal. Okay, another one in that quadrant, 240. So start on the positive side of the x-axis. 240, we'd go 180, and how much more? 60. So for 240 degrees, okay, this is 60. This is 30. And that's critical. If you don't get the 60 and the 30 in the right place, then you're going to miss them. So you got to be thinking. It's 180 plus 60 more would give me 240. Side opposite the 30 is 1. Okay, so this side up here has to be 1, but we're going to the left. So it's negative. The hypotenuse is twice that shorter leg, and the longer leg is radical 3 times the shorter leg, and it's negative because we're going down. Okay, tangent and cotangent ought to be positive in that quadrant. All the rest ought to be negative. Okay, 2 more for the 30, 60, 90. Let's go 300. Okay, so 300, you'd start on the positive side. You'd go 270, and how much more? 30. Okay, so that makes this angle, if we're doing 300 degrees, okay, that makes this 60, this 30, and remember the perpendicular always goes back to the x-axis. Side opposite the 30 is 1. The hypotenuse is twice that shorter leg, and the longer leg is radical 3, and we're going down, so it's negative, radical 3. In quadrant 4, what should be positive? Cosine and secant. Okay, all the rest of them should be negative. Okay, okay, last one, 330. So for 330, I would start on the positive side. I would go around to 270 and 60 more. So 330. Okay, 330 degrees makes this a 30-degree angle inside. Side opposite, and it's -1 because we're going down. The hypotenuse is twice that, and it's always positive. And then the longer leg is radical 3. Okay? Okay, that's the standard labels for the 30, 60, 90s and all 4 quadrants. Okay? If they would give you, let's say I gave you hypotenuse on a 30, 60, 90. If I gave you the hypotenuse was 10, what would the shorter leg be? 5, and then the longer leg would be 5 radical 3. Right? You got to multiply it by radical 3. And then it makes a difference which quadrant you're in, whether it's positive or negative. Okay? You can't ignore the negative signs in trig. Okay? Okay. The 45, 45, 90s. Draw another little separator. Okay, and this is still special cases of 45, 45, 90. And you did these in geometry also. 45, 45, 90 right triangles. Okay. The only difference in trig is we're putting them on a coordinate plane. In geometry, you just had the triangles separate. Okay. Okay, let's look in quadrant 1. So if we did a picture in quadrant 1, we'd start on the positive side, estimate about a 45-degree angle, drop the perpendicular back to the x-axis. So that makes this a 45, 45, 90. Standard labels on a 45, 45, 90. Since those angles are the same, the legs have to be congruent. They have to be the same. And the standard labels are 1, 1. Okay, and if you did the Pythagorean theorem, you would figure out the hypotenuse is radical 2. 1, 1, radical 2. Okay, and that's a 45-degree angle. So that's your picture for a 45 degree. Okay. Now let's go into quadrant 2. Okay, and this one's going to be 135 degrees. Okay, so if we did 135, we'd start here on the positive side, standard position, we'd go 90 and 45 more. Drop the perpendicular back to the x-axis. So this angle's 135 degrees. So this angle inside is 45. So it's a 45, 45, 90. So it's 1, 1, radical 2, but we're going to the left. This part's critical. Okay? You guys already know me. You know I'm going to count it wrong if you don't have the right positive or negative sign. So positive or negative signs, and your check that keeps you from missing that is before you hand in your test, you do a smart trig class. And say, if I'm working a problem in quadrant 2, what should be positive? What should be positive in quadrant 2? Sine and cosecant. All the rest of them. Remember, the S's don't go together. Sine and cosecant. Okay, go together. Those should be positive. All the rest should be negative. Okay, let's go into quadrant 3. Okay, if we do quadrant 3, 225 degrees. We'll do a sketch for 225. So you start on the positive side, go 180 and 45 more. Okay. So this is for 225. So that makes this a 45, 45, 90. Standard labels are 1, 1, radical 2, but we're going to the left. To the left is negative, down's negative. The hypotenuse is always positive. So in this case, if you were doing this would be the opposite, would be negative 1. The adjacent would be negative 1. And then the hypotenuse would be radical 2. Okay, and the last one, 315. 315. So start on the positive side of the x-axis, go 270 and 45 more. Drop the perpendicular back to the x-axis. And this represents 315 degrees. Okay, so this is your 45, 45, 90. And it's 1, 1, radical 2. This one we're going down, so it's negative. And in quadrant 4 it should be cosine is positive and secant's positive. Okay? Okay, so on the board it says you need to do the table. Okay? And that is a handout.